In this video, we're gonna investigate geometric sequence using +viz. As we know, a geometric sequence is a sequence wherein the next term is obtained by multiplying a constant number other than 0. Let us consider a geometric sequence with first term 3 and a common ratio of 2. Alright, let us try to fill up this table using the terms of the geometric sequence. In the second column, we will have the terms of the geometric sequence that we had earlier. Let us now use spreadsheet function to do so. On the first cell A1, press 3 and then equals. Since our common ratio is 2, we need to multiply the preceding term 3 by 2. And then we want to have the next values by using the fill formula. So press options, then fill formula is 1. And then we want to multiply the first term 3 with 2. So you need to press alpha and then the negative sign for 1. And then 1 times 2 for our common ratio. And then we need to fill up our table onto the 15th row. So from A2 to A15, press arrow right and then delete 2, replace by 15. Then press equals and another equals. We have now the terms of the geometric sequence with first term 3 and a common ratio of 2. Copying the data, on our table we have 6 and then 12 and then 24 and then 48, 96, 192. The 10th term will be 1536 and the 15th term is 49,152. We want our third column to be the quotient of the terms of the geometric sequence and 3. Alright, let us do that in our spreadsheet again. Going to B1 using arrow keys. The same thing, we need to press options and then fill formula. And then our dividend will come from the first column, which is A, so alpha and then negative sign, and then 1 divided by our first term 3 and then equals. The entries is until B15, so press equals and another equals. We have now the quotient. Copying all the values again, on our table we have 1 and then 2 and then 4 and then 8. Looking at our +viz for the other values, we have 16, 32 and then 64. The 10th value is 512 and the 15th value is 16,384. Getting the prime factors of our quotient, or having written the quotient with base 2 with an exponent, we have, of course, 1 can be written as 2 raised to 0 and 2 can be written as 2 raised to 1. We all know that 1 as an exponent will not be written, but just for the sake of observation, let's have it as 1. And then 4 is also 2 squared, 8 is 2 cubed, 16 is 2 to the 4th, 32 is 2 to the 5th. Alright, 512. Alright, going to menu 1. 512. And then press equals. To get the prime factors of this, we need to press shift. And then the degree minute second button to get the prime factors of 512. And that is 2 raised to 9. The same process to get the prime factors of 16,384. Press equals and then the prime factors. We have 2 raised to 14. Alright, multiplying the first term and the powers that we have in our fourth column, we have 3 times 2 raised to 1. Let's have rather the grouping symbol. And then 3 times 2 squared. And then 3 times 2 cubed. And then 3 times 2 to the 4th. And then 3 times 2 to the 5th. And then 3 times 2 to the 9th this time. And then lastly, we have 3 times 2 to the 14th. After completing the table, let us try to observe the exponents of the given expression with n. As we can see, the exponents is always 1 less than to the values of n that we have here. So it means it's n minus 1. And we all know that we have all first terms 3 in the expression. And then we all have bases of 2 in the expression. So answering now the guide questions, what can you say about the exponents in column 4, which is the powers, in relation to the values in column 1? Again, as we can see, it's always 1 less than to the given values in n. Observe the pattern in column 5. If you are going to get the nth term of the geometric sequence, what will be your resulting expression? So that will be 3 times 2 raised to n minus 1. And then for guide question number 3, let the first term 3 be a sub 1 and the common ratio 2 be r. Rewrite your expression in question 2 using a sub 1 and r. So therefore, the resulting expression will be a sub 1 times r raised to n minus 1. And this is the nth term of the geometric sequence. I hope you were able to see the relationship between the powers and the number of terms in the given sequence. Thank you, and see you on our next episode.